Everyone. I'm back with one more session on friction. In our previous class on friction, we have discussed about what is a friction, various types of friction like static friction, dynamic friction, classifications of frictions, and also we ended our session with learning a couple of things like angle of friction, cone of friction, and also something called as limiting friction. Today we will be seeing how to solve problems in friction. Before going ahead with problems, let us revise the definition of friction. Friction can be defined as a force that resists the movement of two contacting surfaces that move relative to one another. Also, this force always acts tangent to the surface at the points of contact and is directed so as to oppose the possible or existing motion between the surfaces. Now, how do we solve the problems? In order to solve the problems in friction, firstly, choose a reference axis. It is always preferred to choose reference axis parallel to the contact surface. And after choosing the reference axis, we are supposed to draw a free body diagram, which is in shortly called as FBD. In how do we write free body diagram? In order to write free body diagram, we will be separating the entire component, that is the object and the contact surface, and will be taking only the forces, various forces acting at these two objects. First thing we refer to is self weight, which will always act vertically downwards, and all the external forces that is acting on the component. Next one is frictional force. Frictional force will always be tangential, and it is always opposite to the direction of motion of the object at the contact surface. Also, keep it in mind that frictional force will be parallel to the contact surface. And lastly, we write the normal reaction, which is perpendicular to the contact surface or normal to the contact surface. Next step is to write sigma h and sigma v, or solve for x-axis components and y-axis components. After finding out x and y components, we have a limiting friction equation, which is mu equal to F divided by N. F stands for friction and N stands for normal reaction. Solve all these three equations in order to solve a problem in friction. Now let us see a pictorial representation of how we solve a problem. Imagine we have got a box lying on a flat surface. Now first comes the self weight. Next, a normal reaction perpendicular to the self weight. Next, the forces acting on the object. Here we have taken P as the force acting on the object. Now, because of this P, the tendency of the object is to move from left to right. So the friction will be parallel to the contact surface and in the opposite direction of movement of the object. Hence, it comes in this manner. Now, reference axis is chosen as parallel to the contact surface and perpendicular to the contact surface. X-axis is parallel and y-axis is perpendicular to the contact surface. Now, the free body diagram gets reduced to normal reaction acting from contact point in the upward direction, weight downward direction, frictional force F, and the pull P. Remember one thing, students, the denotation of all the component may vary from one explanation to another. In couple of textbooks and in couple of explanation, this N is taken as reaction capital R and friction is chosen as FR. P may also be taken as F. Going ahead, if at all we have an inclined surface, how do we solve the problem? We have the weight of the box acting downwards and reference axis is chosen at that point parallel to the inclined surface, and if the surface is inclined at an angle of theta, the weight of the box will be inclined at theta to the reference axis. We have x component of this weight W and y component Wy. Since this is acting downwards, for the chosen reference axis, it lies in third quadrant. Hence, both x and y component will be negative. We have the applied force P, and since the box is being pulled upwards, frictional force will be acting downwards. The same thing, all the forces acting. Let us just remove the object and the inclined surface. The entire sketch gets reduced to Wx, x component of weight W, y component of weight W, normal reaction, friction, and the pull P. Now let us see how to solve a problem. Here is a simple problem in friction, wherein a block shown in the figure is just moved by a force of 200 Newton. The weight of the block is 600 Newton. Determine the coefficient of static friction between the block and the floor. Now, if you look at this sketch, it is clear that the box is getting pulled from left towards right. As per the definition of friction, the friction will be in the opposite direction to the movement of the object and parallel to the contact surface. So it has to move from right towards left. Now let us write the free body diagram before solving the problem. 600 Newton is the weight of the block, and in the opposite direction to the weight, we have normal reaction. The force is being pulled at an angle of 20 degree, and the friction moves from right towards left. Reference axis is chosen this way. Now to write the free body diagram, we have 600 newtons acting downwards, normal reaction acting upwards, F acting from right towards left, and a 200 Newton weight, a 200 Newton force pulling at an angle of 20 degree with respect to x-axis. This 200 Newton can be resolved into x and y component as 200 cos 20 degree and 200 sin 20 degree. The same thing is given over here. Now, after reducing the sketch into free body diagram and representing all the forces acting on it, we have three steps, that is sigma h is equal to 0, sigma v is equal to 0, and mu is equal to f divided by n. Sigma h is equal to minus f plus 200 cos 20. Therefore, f will be equal to 187.93. Sigma v is n plus 200 sin 20 minus 600. Therefore, n is 531.59. Thus, mu is equal to f divided by n. Hence, mu is 0.35. Going to the next problem, we have a box on a inclined surface which is inclined at 25 degrees to the horizontal surface. The weight of the block is 500 Newton. It is supported by an effort P which is parallel to the plane as shown in the figure. Determine the minimum and maximum value of P for which the equilibrium can exist if the angle of friction is 20 degree. And one more component is given over here which states impending motion of the block. Impending motion of the block is to indicate that the block is moving. Impending means there is a movement. Now, what are we supposed to find out? Even before understanding what we are supposed to find out, let us look at the box and what are the data given over here. As looking at the data, it is very clear that if there was no force P, the tendency of the block is to slide downwards. So, we are supposed to find out minimum and maximum value for which the box will remain in a state of equilibrium. That is, minimum is the value of P because of which the box will not slide down. This is first component. Not sliding down indicates that the system will be in equilibrium. Next comes the maximum value of P. Maximum value of P is the value beyond which the block will start moving in the opposite direction. So remember very carefully, minimum is the value for which the block will not move downwards. Maximum is the value because of which the block will start moving upwards. These two forces are to be found out in the given problem. Now, case 1, impending motion downwards. This is the default system, or default, by default, the box will be moving downwards. Now, how do I write various forces? Let us assume x-axis and y-axis parallel and perpendicular to the contact surface. Next comes the weight, 500 newtons, which is inclined at 25 degrees to the vertical component. Now, next is resolving 500 newtons into vertical and horizontal components respectively. Next comes normal force, which is perpendicular to the contact surface. Next comes the applied force P. General tendency of the block is to move downwards. So the direction of motion is downwards, and friction has to be applied in the opposite direction. Hence, F will be in the upward direction. Now, these are the various forces acting on the block. Now, these things are to be separated from this block and this inclination. The entire sketch gets reduced to, before going into free body diagram, instead of giving coefficient of friction, angle of friction is provided. What is angle of friction is, imagine the resultant of F and N to be R. Remember properly, resultant of F and N is R. The angle at which the resultant of F and N is subtended with the reaction will be called, with the normal reaction, will be called as angle of friction. That is 20 degree given. Now, what is the relation between coefficient of friction and angle of friction is, coefficient of friction, we know coefficient of friction is F divided by N. Thus, tan of phi, that is angle of friction, tan of angle of friction is nothing but coefficient of friction. Solving this, we get coefficient of friction as 0.36. Now, next, writing the free body diagram, separating all the components in it, we have got normal reaction, 500 cos 25, 500 sin 25, F and P. Solving with our usual denotions, summation of V is equal to 0, thus N will be equal to 453.15. If N is 453.15 and mu is equal to 0.36, F will be equal to 163.13. Summation of H is equal to 0 minus 500 sin 25 plus F plus P is equal to 0. Therefore, P should be equal to 48.17 Newton. That is to say, if any force less than 48.17 is applied as P, the object will be sliding downwards. And when you apply a force equal to 48.17, the object will stay stationary and it will be in equilibrium. Coming to the second case, impending motion upwards. That is, the box is supposed to move upwards. If the box should move upwards, the friction will be in the opposite direction. Similar to the previous case, let us assume x and y axis vertically downwards. Sorry, this should have been 500 newtons. We have horizontal component, vertical component, normal reaction, the applied force P, and the friction. Just like in the previous case, mu will be equal to 0.36. Writing the F body diagram, F which was to the right or which was in the positive component now becomes the negative component. Solving with summation of V is equal to 0, N will be equal to 453.15, and since mu is equal to 0.36, F will be equal to 163.13. Now applying summation of H is equal to 0, we can solve P to be equal to 374.43 Newton. So now what does P equal to 374.43 mean is, for any weight which is equal to 374.43 Newton, the box will remain stationary. And for all the values greater than 374.43 Newton, the box will start moving in the upward direction. Minimum force required to keep the block from sliding down is 48.17, and minimum force required to slide the block upwards is 374.43 newtons. We will see how to solve various other kinds of problems related to friction in our coming slides. Thank you.